Hi, welcome, Dr. Gershon. I'm Heidi Firearm Smith, and I'm with the Love Chloe Foundation. And we are so glad to have you today to talk about your grant for T cell therapy for DMG. And before we get started, though, I just want to say on behalf of the 28 members of the DIPG DMG Collaborative, we would like to award you with this $200,000 grant.
Wow.
So,
Well, that's a great way to start. I'm thrilled, absolutely thrilled, and deeply honored to be able to work with the support of your foundations. Thank you.
you're welcome. And Tamara would like to say a few words.
Hi, my name is Tamara Ikas, and I am the president of the Reflections of Grace Foundation. Our daughter Grace was 5 years old when she had DIPG, and I'm also the vice president of the DIPG DMG Collaborative. We just wanted to welcome you, and we're just thrilled to be able to use these hard-earned funds from our foundations to support your work. And I want you to know how valued you are with us, and we are just so proud to be able to give this to you. And
Thank you. I would actually turn that right around and say that the support of parent and advocates like yourselves is, uh, a key thing that keeps us going. Yeah, so many things about DIPG is hard. I have counseled many parents of children with DIPG. I've taken care of kids with DIPG. I've done research in it. Um, it's a tough, tough disease. It's a tough climate to be trying to do research. And we really have to band together. It's a thrill to meet you. And like I say, a deep honor to be able to work with your support.
thank you. I'd like to pass it up to Grace now.
Hi, Dr. Gershon. My name is Grace, and I'm with the Cure Starts Now. I'm also a sister of a DIPG angel, Elena. And I just want to say thank you for investing in our kids and for the passion and all the love you've clearly poured into this. It means the world to everyone who's in the fight and for those of us who are continuing the legacy of our kids and siblings. So thank you. And I want to pass it off to Keith because I know he has some questions.
Sure. Before we go further, though, again, I want to thank you and turn it around. Y'all are fighting the fight to allow us to do this research and to support children with DIPG now through improved technology and for the future children who are going to have it, because we know there are going to be more of them. And so thank you. It's an incredible honor to be able to partner with you.
Thank you.
Well, Dr. Gershon, as you pointed out, it's always easier to talk about a grant after we award it. And that's partly what we also want to do. I'm Keith Desserick. I'm with Cure Starts Now, co-founder of the Cure Starts Now and also the DIPG DMG Collaborative. We're glad to see this support of it. And this support, is huge, to be honest. Between our organization and the DIPG Collaborative members, this spreads to I think 6 different countries and 86 chapters and foundations that have come behind your grant. So that's that. We're tremendously supportive of it. But part of what we want to do is not only give you funds in these meetings and talk about it. But we also want to talk about the grant too, because what made this worth funding is really the novel way that you focused on these gamma T cells. And, I know this is a real kind of dense grant in many ways. And many of the comments we had from our medical advisory committee was that there's really a lot to accomplish. But are you able to kind of unpack that for families and help them understand really what makes this different in the CAR T realm from some of the other trials out there?
Yes, sure, absolutely. So as you know, the CAR T cells have have had some success in DIPG, and this is incredibly exciting because it's been hard to have anything have some traction and show some success. But at the end of the day, what we really need are cures. And it's not enough, I think, to just stall out on CAR T cells look like they're in advance, but how can we improve these promising results from the initial CAR T cell trial and take this further? It would be an unusual situation where the first iteration of the technology was the best and nothing could improve on it. And I think it's more likely that now that we know this is a good direction to be going in, we need to think about new variations and new designs that may be more helpful. And so it turns out not all T cells are exactly the same. And the T cells that uh, people have worked with are the ones that grow most effectively using the methods that were known to get T cells to grow. And those are called alpha beta T cells. I didn't make up the name, we're just, that's the name. And these alpha beta T cells can be genetically modified to express CARs, which are chimeric antigen receptors or cell proteins on the cell surface that direct these T cells to get them to attack the tumor. And this works. It's amazing it works. It's really a culmination of decades of people working on this technology, and it's really something, and it's great. But CAR T cells, when we inject them into the brain, we know this from both animal models and human studies, um, work for a little while and then they stop working. And then the question is, should we inject more of them? Will they work better next time if we do repeated injections? But it came to my attention, and again, this is not, I'm a neuroscientist and a neurologist, so T cell work is something I've been kind of catching up on in the last few years myself. When I came to Emory, I found that I was surrounded by people who work in a different kind of T cell called gamma delta T cells. And these are simply, if you take T cells and you culture them in slightly different conditions, the T cells that grow up are predominantly these gamma delta T cells. But this type of T cell works very differently. The classical T cells um, use the T cell receptors to recognize tumors or other foreign pathogens. Gamma delta T cells actually have a different way of recognizing pathogens. It's a little bit more primitive, as it were, rather than adapting to proteins that, are new to the body. So you get an infection, there's new proteins, the immune system learns to recognize them. There's an older system evolutionarily where T cells are simply kind of know what to look for, and when they see something that doesn't look right, they attack it. And that's what these gamma delta T cells are. And so they recognize pathogens or things that need to be removed from the body through a different process. And they don't necessarily need a CAR to recognize tumor cells. My colleague who's on the grant, Dr. Trent Spencer, actually has a clinical trial going in adults with glioblastoma using unmodified gamma delta T cells. And he has data to support the idea that these already will attack the tumor. But one of my other colleagues at Emory, Hunter Jonas, who's also on the grant, has actually pioneered the idea of putting the CARs, like we use in regular T cells, onto gamma delta T cells. And she found, looking at neuroblastoma, a different type of tumor outside of the brain, that this actually makes a kind of T cell that seems even more aggressive than either unmodified gamma delta T cells or classical CAR T cells. And so I thought, well, why can't we bring this innovative technology to to brain tumor treatment? And why not start with DIPG, where this need is so great and where CAR T cells have already shown that there can be a beneficial effect. Um, so I'm a little bit of an itinerant. I was at UNC Chapel Hill for 13 years before I came to Emory. And there I had started collaborating with Dr. Doty, who's also on the grant. And Dr. Doty is one of the world leaders in CAR T cells. And through the sheer force of his ability, he's managed to actually create a CAR T cell program at UNC where their brain tumor program was not very large. So this is really a big achievement. He's an excellent guy. I've enjoyed working with him for years. So I reached out to him when we first became aware of the BFG grant, and with the encouragement to try to span two universities, I said to Pietro, why don't we get together and work on this? And we brainstormed different approaches, and I mentioned this technology with Dr. Jonas, and he was really excited about it. So then it seemed like we had a bunch of pieces falling into place. We have a CAR T cell expert. I have a gamma delta T cell expert. In fact, two, Dr. Jonas and Dr. Spencer. And in my hands, in my lab, we do a lot of animal models. Um, we're fortunate that we also recently recruited Dr. Dasgupta, who does animal models of DIPG. So he and I, so we can hold down the animal model part. And my lab has developed expertise because they've trained with Dr. Doty in making T cells, and now we'll be making CAR T cells from the gamma delta T cells and from the regular T cells, and comparing to see which one is more effective. Um, there's one other component to the grant. Uh, Whenever we do a T cell therapy, we're putting something new into the brain, and it's intended to function as immune cells. But the immune system doesn't just kind of work in isolation. The immune system is a system that has pieces already in place in the brain. So when we inject CAR T cells, these CAR T cells interact with CAR T cells that are already there. Sorry, with immune cells that are already there. Specifically, what we call tumor-associated myeloid cells. These are the microglia of the brain, and they're a kind of immune cell. They're not T cells, but they're a kind of immune cell, and they sit there. And there's a concern that when we do CAR T cell therapy, the existing immune cells in the brain, these myeloid cells that are microglia, may not interact in a beneficial way with the CAR T cells. The microglia may recognize them and say they're not supposed to be here. One of the things microglia do normally in people who don't have brain tumors is keep T cells out of the brain. And we think that's important for normal brain function not to have T cells there. People don't generally have T cells in the brain. And so one theory of a limitation in CAR T cells is that the existing immune cells that are there in the brain oppose these outside T cells that we're injecting, even if they're raised from the same person, because T cells are not typically supposed to be in the brain. How could we solve this? So I have another colleague at UNC that I've worked with for many years, Dr. Sokolsky, who's invented a drug that can go from the blood into the brain and repolarize the immune cells of the brain. And this is this drug that we mentioned in the grant called Resopox. And we think that it may condition the myeloid cells, these microglia, tumor-associated myeloid cells. In the grant we abbreviated as TAMS, TMS, um, to to be more conducive to fighting infection and allowing T cells to be there. Um, and so we think that this is our second aim in the grant. Everything we do in aim one with CAR T cells, gamma delta CAR T cells, regular gamma delta cells, or no cells, we're going to do in aim two only with this drug added. And the idea is then we're going to basically have six different shots, right? There's one control group in each of the two aims, three experimental groups. There'll be six different combinations that we're going to try in order to find which is the best, and identify something that we can go forward with for a clinical trial. In addition to taking these six shots at finding the best, we're going to do studies to try to understand how all these different cells are interacting with each other and how this drug is changing these interactions. We always want to hit a home run,
Yeah.
but in the event that we don't hit a home run, we want to still learn something from what we've done. And so these analytic studies are important because if we don't get what we want, we want to at least learn how we can tweak it for the next go round. So
Well, and
that's my
that's
quick summary of the grant.
yeah. Well, and we're nodding our heads because this does tie into the some of the grants that we're funding in this cycle. It also ties into some historical research that we have funded. There's about 3 grants that our medical advisory committee said that this ties and connects with, and it's extremely collaborative in what you've done as well. So. Once again, congratulations. And we look forward to seeing some of the progress coming from these grants and this work in the future.
Thank you. I'm certainly excited to fill in my collaborators. I know they'll be thrilled, and on their behalf, I'll just say thanks to all of you.